Alright, problem number 4, same deal, graph the hyperbola, find the foci and the asymptotes. Pretty much let's just do everything though anyways, just for fun, just to make sure we can. Um, so let's go ahead and complete the square on x and y so we can get the standard form equation in rectangular form. Then we can know our a value and our b value, and we can find our c value, and we can write the equation and in parametric mode, and we can write the equation of the asymptotes. Yay, all of those things. So first off, recognize already that y has a negative coefficient, so that's already telling me that this hyperbola is going to be opening horizontally. But anyways, first step, factor out that negative 4 from your y terms. So we're going to get negative 4 times y squared plus 4y, because 4y times negative 4 is negative 16y, plus x squared minus 2x, nothing to factor out there, equals 19. So now let's go ahead and complete the square. We're going to get negative 4 times y plus 2, quantity squared, plus x minus 1, quantity squared, equals 19. But then from our y term we get 2 squared is 4 times negative 4 is minus 16. And we get from our x term, negative 1 squared is 1, so we need to add 1 on this side as well. And now let's simplify that. 19 minus 16 is 3, plus 1 is 4. Pardon me, I burped. So let's go ahead and divide by 4 to make this look a little bit more normal. I'm going to write it as x plus 1, quantity squared, put that one first, divided by 4, minus 4 divided by 4 is going to give me y plus 2 squared over 1 equals 1. And I'm actually going to write that 4 as a 2 squared, because I like being able to see my a and b values easily. So a is 2 and b is 1, and this is a hyperbola, so c is going to equal the square root of a squared plus b squared. So c is going to equal the square root of 5. Cool. And by now we should love that number. We already know it's like 2.23 roughly. Wiggle those equal signs. So let's go through. First off, let's parameterize this mug. X equals, let's say 2, and this is going to be secant of t because x is positive, minus 1. Y equals tan of t minus 2, and again 0 less than or equal to t less than or equal to 2 pi. Now what's left to do? Let's sketch the graph of this function. And real quick, small mistake, notice right here I changed my sign on accident from a negative 1 to a positive 1. So let's go ahead and fix that in our equation. That should be x minus 1 squared, which means that in our parameterization we should get plus 1 there. So yes, mistakes happen. Make the mistakes, it's okay, but try to catch them and change them yourselves. You can do that. So now let's graph this. From my parameterization, it's easy to see that my center is going to be at 1, negative 2, so let's plot that. Remember, we know that this parabola is opening horizontally, which means my a value of 2 is in the horizontal direction, so let's go 2 to the right, 2 to the left. Let's go up 1 and down 1 to get our box. So I've got my box and my asymptotes drawn in, and now we can actually sketch this graph. My vertices are going to be right there on my box. At y value is negative 2 for both of them, x value of negative 1 and of 3, And now we can sketch that in on both sides. Make it look as decent as you can. That doesn't look great, but it looks okay. I can get my foci in there as well because I need to go 2.23 to the right and left from my center. So I'm going to get the points 1 plus or minus the square root of 5, comma, -2. And let's see, what else do we need to do? We want to write the equation of the asymptotes. Well, look at our equation in standard rectangular form, because then we know we can write the equation of the asymptotes as y plus 2 equals plus or minus. Now remember, it's either going to be b over a or a over b. But think about our graph. A is between 2a rather is between our vertices. So a is horizontal, and we need to rise over run. So we're going to need a over b. A is 2. Or I'm sorry, we're going to need b over a. I apologize. So we're going to get 1 over 2. So it's going to be 1/2 times x minus 1. And now we are super done.